Good day everyone. Welcome to our third video in Statistics and Probability, brought to you by VNHS Senior High School Mathematics Group. Again, this is your Statistics and Probability teacher, Sir Neil, and on this video, I will be discussing about our third lesson, which is Probability Distribution of Discrete Random Variables, Part 2, illustrating discrete probability distribution. Now, are you ready to learn? Very good. So, for us to start, let us have a review of what is discrete probability distribution. Discrete probability distribution consists of values a random variable can assume and the corresponding probabilities of the values. Remember, in our previous video, we learned how to identify the values of a random variable. Now, let us have the corresponding probabilities of the values of a random variable, which is the question, how do we get the corresponding probabilities of the values of a random variable? To answer that, let us take our first example. As mentioned, illustrate its probability distribution if our random variable x is the number of heads in tossing a coin twice. Use h if it is a head and t if it is a tail. To start this, let us remember that this is the same example in our previous video, and you are expected to have mastered how to get all the possible outcomes of an event and identify the values of the given random variable. So, the possible outcomes are HH, HT, PH, and TT in our previous video. Now, the values of our random variable x would be, which is the number of heads, for HH that is equal to 2, HT is equal to 1, PH is equal to 1, and TT is equal to 0. Now, let us illustrate or create our probability distribution, which consists of the values of our random variable x and the corresponding probabilities of the values of x. So, in the column of our x, we only list down the unique values, that is this one here. We get the unique values here, and that is 0, 1, 2. Now, to determine the probabilities if x is equal to 0, we need to count the number of zeros here. Since we only have 1 0 out of 4, then our probability if x is equal to 0 is equal to 1 over 4, or that is equal to 0.25. Now, to get the probability if x is equal to 1, then we only need to count the number of 1 here. So we have 1 and 2. So, the probability that your x is equal to 1 is equal to 2 over 4. Since we have 2, 1 here, that would be 2 over 4, or 0.50, 0.5. Now, lastly, what is the probability if x is equal to 2? Then we count how many 2's here. So, we only have 1. So, the probability is 1 out of 4. So, that would be 1 over 4, or 0.25. So, it is quite easy to get the probabilities of a random variable x if we already have all the possible outcomes with corresponding values of x. To master this process, let us have another example. As mentioned, suppose you are to test 3 random eggplants from a harvest to see if there are worms in it. You want to find out the number of eggplants attacked by worms. Use W to represent if there is a worm attack in an eggplant, and N if there is none, to identify the values of X. So, to illustrate our probability distribution, the possible outcomes would be WWW, WWN, WNW, WNN, NWW, NWN, NNW, and NNN. So, if you will remember, we already get the possible outcomes last video, so we only need to list down all of this. And the corresponding values of these possible outcomes, or the values of a random variable X, which is the number of eggplants attacked by worms, is equal to 3, 2, 2, 1, 2, 1, 1, and 0. So, we will now have our discrete probability distribution. It consists of our random variable X and its corresponding probabilities. Now, to know the values of the random variable X, we get the unique values here. Then that would be 0, 1, 2, and 3. Okay? Now, the corresponding probabilities for each random variable X here, let us start with 0. What is the probability if your X is equal to 0? We only need to count how many zeros here. So, we only have 1 out of 8. So, the probability is equal to, okay, very good. That is 1 over 8, since it is only 1 here out of 8. Or that is equal to 0.125. Now, let us have the next one. If X is equal to 1, what is its corresponding probability? So we only need to count. That would be 1, 2, and 3. So we have 3, 1 out of 8. So that would be equal to 3 over 8, or that would be equal to 0.375. Okay? Now, the next one is 2. So we only need to count how many number 2's here. So 1, 2, and 3. So that would be equal to 3 over 8, or that would be equal to 0.375. And lastly, we have 3. So we only need to count how many 3's here. So that would be 1. So 1 out of 8. So the probability that your X is equal to 3 is equal to 1 over 8. Or that is 0.125. Now, you only need to remember is that we need all the possible outcomes with its corresponding values of X. Now, we only need to count the number of, or the repetition of the event with its corresponding values to determine the probabilities of each values of our X. Okay? So, are you ready to test your understanding about illustrating discrete probability distribution? Great. Now, let us have discrete probability distribution. As mentioned, this is supplemental activity 2. Determine the probability distribution of the given event below by completing the table. Suppose a team will be playing 4 consecutive games, and X is the random variable for the number of wins. Let W represent the win, and L represent the loss. So, you only need to complete this table the way we have done it in the process in our previous slides. Okay? So, this ends our lesson. Thank you for listening and God bless.